Welcome back, everyone. Welcome to my math online today. Today is a day when I'm looking through the window, I see a color different because not so raining, but also not so sunshine. That makes our worlds have a varieties and beautiful in another look. So I mean, in our society, we have all kinds of skill and knowledge and skill and talented. Each of us contribute to a society and make a different perspectives. So if you watch me online on YouTube, you will find another way of all of us are different way in the way we teach, in the way we communicate, in the way we deliver our mathematics education. I hope that you will find some kind of interesting from my video online, and that's why I'm looking forward to hope that my contribution for the global education has an impact, and some of you will find an interesting from my videos. Now I know that we have all kind of fabulous technology that I never dream of how I can make my video more and more attractive, just like those professionals out there. But as I said, each of us are different in the way that we contribute. So I hope that my videos not appears too bad for all of us. So yesterday I was mentioned about mathematics education is very important because we are in the time of digital evolution. And without mathematics, we don't have technology. Without technology, we don't have an interesting mathematics lesson. However, there are some basic foundation in mathematics, even though a little bit very simple, like an X or Y or the multiplication table, never been faded through times in history, the pi number. So we keep the basic core mathematics foundation stay as the way it is. And we base on that, we move forward, we make on the top of it more progress. But I still believe multiplication table is so important. And that's the foundation of mathematics. Anyway, the lesson today you will learn with me will be, and let me straightforward to get into the lesson today rather than advertising for my math online videos. However, I wrote it online there. Sorry, I'm just seeing something on my screen. And so I wrote online here, mathcoursesonline.teachable.com. Now, working as video, sometimes I forget to press the record button, and then all my lesson is gone, and I have to go back and teaching the whole thing. So let you know that this is not easy work, to be honest with you. We stand here looking like easy tasks, but actually we spend a lot of time to prepare our lesson plans and online lesson and everything. And sometimes we don't like the way we do, and we have to record the whole tape. And And as I said, sometimes even though I forget my record buttons and everything gone after I take the whole lesson, then I have to re-record again. This is not an easy work, the same like anything you do, but you do for passion, for the sharing knowledge and for passion, right? So I have enough energy to get going. Anyway, let me get right into the question now. We have the question. Get the rational function f of x equal x squared plus 3x over x squared minus 4. Now, I have went through with you about the analysis of rational function. And I have shown you why does the rational function have asymptotes. And I already explained in my previous video, so I will go through a little bit, not like a tedious detail talking about vertical asymptotes or horizontal asymptotes, so that I can move on and give you some more information, right? So in this question, we will get the rational function. And the question asks us to label on the asymptotes, intercepts, state, domain, and range. Now, yesterday I have shown you how we get the rational function based on the linear on the top as the numerator and the linear at the bottom as denominator. Today we progress to the degree of 2. The quadratic on the top, the polynomial on the top, with the degrees of 2 rather than just 1. So before we do this, sorry, excuse me. Before we do this, let me factor out the expression, right? So I'm going to factor out the expression. This will be x times with x at 3 divided by x. And now this is a squared minus b squared. So I'm going to factor it become a plus b times a minus b. This is the difference squared. And you learned this in math 10 already, right? So our a here is x. So we will have a x plus 2 times with the x minus 2. Follow this formula. So now, the way we sketch the rational function is we want to find out first. Let's talk about the basic one again, recon a little bit, right? 1 over x. So the basic shape have a shape something like this. And this go to 1 and 1, and this go to minus 1 and minus 1. And we have a shape of rational function look like this. And we notice that our y-axis here is the vertical asymptote for the basic shape. And our x-axis is the horizontal asymptote for the basic shape. And the reason because we not allow for any fraction have a x equals 0. It got to be different from 0 to make the fraction valid. And therefore, we know that at x equals 0 right here, we have a vertical asymptote. So in other words, to find the vertical asymptotes mean we try to look at where the denominator becomes 0. And therefore, the function at that point does not exist. And you can see from basic graph here. The graph here doesn't go through the asymptote. It shape along with the asymptote, but they never touch it, right? And thus we mean the asymptotes. So by looking at this, we know that our vertical asymptote will be equal solve for x bracket and set it equal 0, we know it equal x equal minus 2. Also, for the next bracket, if we set equal 0, we solve for it, we have x equal positive 2. So this is our vertical asymptote. And let's plot it, right? So minus 2, which is right here. Let me draw the vertical asymptote. And I found that the math has become interesting when we go at this level. We see a little bit variety, right? Rather than a boring multiplication table. So we have a negative 2 as the vertical asymptote and positive 2 as the vertical asymptote. And I like to sketch this stuff by hand rather than using our calculator. Now, as our technology invention in order to help mathematics, and we use technology as a tool for our mathematics, not for replacing it. That is my opinion, my philosophy in my teaching. So I still prefer sketching this function by hands rather than looking at the roughing calculator and analyze it. Now, if you look at the roughing calculator, it's a lot faster and easier, and you can analyze, but sometimes it's gone quickly, right? It not retained in our memory. But if we learn how to sketch by hand, in Math 12 with calculus, we'll be able to analyze and we remember it more easily. That's my ideas about teaching mathematics. We don't want to use technology to replace our math. We want to use it as a tool. We sketch by hand and we check by drafting calculator. Okay, so now let's see. We have vertical asymptote. Next, we'll look at horizontal asymptote. And what is the horizontal asymptote? Now, the horizontal asymptote in the basic graph here show us we have to look at the x value when it's getting very large to positive infinity and negative infinity to see where is our y value at. So here our y value at 0.00123 or something, right? It never touched this. So when x getting very large, the y getting close to 0 from the basic graph. But from this graph, what does it look like? Now, remember yesterday I told you that when x getting very large, all we care is about highest degree. And we don't have to worry about a million here for x. And when we power it, and even a bigger, we take away -4. If you have $1 million and you take away -4, that doesn't make any difference, right? And therefore, to find the horizontal asymptotes, you look at where the x getting very large number. Ignore anything else insignificant, right? So we'll look at here, we say, Richard care about x squared, divide by x squared here. The highest degree on our function. Ignore this one, pretend they're not there. And what happened? X squared divided by x squared equal 1. And this is the y function because f of x is y. So y equal this. When x getting very large to positive infinity or negative infinity. And because even though if it's negative, but if you square it, it will become positive anyway, right? So it doesn't make difference. So now we know our horizontal asymptote for this function is, we look at the coefficient in front of the highest degree here. and that's the hint I give you. So 1 divided by 1 equals 1. And our horizontal asymptote is y equals 1. So I'm going to mark it, our horizontal asymptote here, y equals 1 for our function. What else do we look at it? We will look at it, the y-intercepts and the x-intercept. So now we know horizontal asymptote is what? Y-intercept. How do we find y-intercept? We find y-intercept by setting x equals 0. So let's set x equals 0 in this equation. What is our y-intercept look like? And of course, x is 0. We're going to find out y here, right? So if x is 0, this is 0, square 0, 0 times 3 is 0. Now, as long as the top is 0, everything else of the function is 0. So our y-intercept is 0 and 0. Now, let's take a look at x-intercept. What is our x-intercept? Our x-intercept happens when the y equals 0. So let's set this function equals 0 and solve for it. So we have 0 equals x squared plus 3x over x squared minus 4. Now keep in mind this is 0, right? Now I'm going to kick this bottom up here. That's the way I solve the equation. I'm going to do quick because I don't want to go slow at this point. Everybody know how to solve the equation. Instead of multiply both sides by this, the same like I'm kick this up here. Divide become multiply. So I will have x squared minus 4 times 0 actually become 0, right? So I will have this equals 0 because I kick this up at time with 0. Anything times 0 becomes 0. I left with x squared plus 3x. Now I'm going to move the, wait a minute. Yeah, that's right. So I'm kick this up and that becomes 0. So I have this 1. So let's solve for this. I'm going to factor this. So our x-intercept will be 0, one of this bracket here, and the other one will be x plus 3 equals 0, which is x equal minus 3. So our x-intercept, so I kick this up to find x-intercept, set y equals 0, this becomes 0. I will have x equals 0 and x equal minus 3. That's right. So I know our x-intercept will be right here. Let's mark it, minus 3 and 0. Our y-intercept, so let me put in here, our x-intercept is 3 and 0. And anything else is the irrelevant. I'm going to erase it. So we have more room, right? Okay, so now I have x-intercept, y-intercept right here, and x-intercept right there as well. So how do we sketch this function? To be able to sketch this complicated function, we have to know where do we put our pen. Now we know that the function will go through here and here, but we don't know where is our pen. We have two vertical asymptotes here. Do we put our pen right here, or right here, right here? We don't know where to start our pen, right? And that's the point. We have to know the vertical asymptote here, and we have to know, do we put our pen down here to start our graph and go to this point, or do we put here and go to this point? So to do that, we have to take a look at our vertical asymptote when x equals minus 2 on the left side and when x equal -2 on the right hand side. Because we don't know where to put the pen, on the left here, in the middle here, up here, on top or somewhere, right? So we start from there, okay? So now let's take a look at where x approach to -2 on the left. So our function is this one, right? This one. If we want to look at the x approach to -2 on the left, what I do is put in here the number value. Let's say I have -2.001, and I'm gonna, it over -2 a little bit, right? Because it's on the left here, this is -2, so it go over, it's going to be -2.001 or 2.003 or whatever, right? Okay, so we're gonna square it, and we're gonna say this is 3 times with -2.001. All of this will be divided by 2.001. We square it, doesn't matter, negative, positive, square should be the same, -4. Now, by inspection, I know that I'm going to get some kind of number on the top, right? I know that I will get some kind of number on top. And this is a negative number. So this will be -6 point something something 003. This might be 4 point something something, right? And you add into it 4 and 6 is maybe 10 point something something, right? Just like that. If you want to be more accurate, maybe I can key in. I'm not lazy anymore. Let's key in and find out, okay? Maybe for first example, we can figure out accurately and see what happened. So I'm going to key in accurately. 2.001 squared will be 4 point. Otherwise, you don't believe me, right? 004 minus 3 times 2.001, 6.03, divided by, this will be the same. Now, it turned out, what happened? It turned out this will be subtract this one, so we have -2 point something, right? Or even 1.99 something. Let's do accurate. -4. Okay, I will get here -1.999. Divide down here will be 0.004. And this is positive. So negative divide positive will become a negative. Now, remember, this number down here is a decimal number. And if you turn out a fraction, you will have 4 over 1,000. And the 4 over 1,000, if you divide by a 4 over 1,000, you twist the fraction upside down. So it's like you multiply with 1,000. Right? So therefore, you know that the answer for here is a very large number. And we can consider the large number here. Remember, this is just the example we put in. It could be 2.000001, as long as a little bit on the left of this vertical asymptote, right? Minus 2.000001. And imagine if you have such a small number like that, and you divide, it turns out a huge number, right? As long as our decimal is have a lot of number, of a lot of digits. So now you know that we can imagine this become a negative infinity. Anytime we have a number, doesn't matter big or small, we divide by a very small number, it turns out to be a big number, the opposite, right? And we know that we can represent this by negative infinity. So now we know that on the left of this vertical asymptote, x equal -2, our pen will be right here, which is negative infinity. So we know we can put the point right there. We can use our pen, we can put it right here. let exempt means what if our pen, where do we put? Up here or down here? If our number for if our value of y value on the right hand side of the vertical asymptote, right? So let's examine that. And we're going to use the same example in here because the number are not going to change, right? Except that the sign might be a little bit different. So imagine this is exactly the same number, but if we over the 2 a little bit, minus 2 point to the right, it will be 1.99. So this number, instead of 2.001, will change this become minus 1.999. And therefore, this as well will change into minus 1.999. And therefore, this number will be slightly a little bit different from here, right? But still negative. And I don't know, I just estimate, right? I don't know, maybe less than a little bit, 5.999. Okay, let be a little bit casual, right, for now. And now this number as well will be changed into negative 1.999. Now, the dynamic will not be the same, but let's find out 1.999 and square it. It will be, this number here will be equal to 3.996001 minus 4. Now, obviously, this number with the negative sign will win this 1, right? So on the bottom, we will have something decimal like this as well, but the sign will be negative instead of positive because this number is winning. Minus 4 subtract 3.999 here will be minus. And out up here, this number, let me draw it to you. Okay, so 1.999 square it will be 3.996, the same like this. Adding with this in negative, this number still win this number. So this number is still minus. Down here minus. So everything is not changing except the sign will be changed. So instead of we have a negative infinity, now it become a positive infinity. And therefore we know we can put our to this number line, a vertical line of minus 2, we can put our positive infinity, our pen will start from there. So that's how we analyze the value of y when x approach to this number. Now let me write down so that it doesn't look so messy, right? So what we do here, we say if, and I put the asterisk, so it's important. If x approach to minus 2 to the left, then y will approach to minus infinity. And the arrow show the approaching, right? If x approach to negative on the right hand side, which is the positive on the top a little bit, y will approaching to positive infinity. Now we're done with the one vertical asymptote. We're going to have to go to another one here. If x approach to positive 2 on the left, y will approach to what? So let's take a look at it. And we're going to use the same example here, right? Now, except that anything else will change. If x is 2, but it close the 2 on the left, we can assume our x is 1.999. So this doesn't make any difference because negative squared, just same positive. Squared positive. This one doesn't change, right? Similar like that. And down here, what happened? Down here will be the same, exactly the same. We will have a negative on the top, but this number is is less than this number, right? 1.999, then this number will win. So we will have a negative on the top because of this. And therefore, down here will be negative. So we will pick this side, right? So we will have y approach to positive infinity. If we look at, no, okay, sorry about this. So we look at 2 on the left. So that, yes, our number will be 1.999 squared minus 3 times with positive 1.99. So actually, we do have a positive on top. And the bottom, we have a negative. So it turned out to be a negative, right? For the second case, right? Because this number will be positive 1.99. So we multiply this, it will be positive. And therefore, we have a positive on top divided by a negative at the bottom. So our y approach to negative infinity. So to the left, we can put the pen out here. Now let's look at when x approach to, so we know that it will be negative infinity. If x approach to positive 2 on the right hand side, our y will be approach to, if it is positive, then this one doesn't change. And this will change because what? This will change become 2.001, right? Over 2 a little bit, but everything will be positive. So the top still positive. The bottom will be a scenario. When we have 2.001 and we square it and we subtract this, this would be our width, this one. So this will become positive, bigger than this a little bit, like 4.004 minus 4 will be positive 0.04. And therefore, this will be positive. So now we know y will approach to positive infinity. If x approach to 2 on the right-hand side of our vertical here. So we know our pen was somewhere here, positive infinity. We know that. Okay, so at this point, we almost be able to sketch our graph. But let's see how we need to figure out, what else do we need to figure out? Okay. So we know that the function will go through this, right? And we'll hit this one as well, and we will shape it along with the vertical asymptote, and it will go somewhere here, and it go like that. Very much similar to what we do on the graphing calculator. Now one more thing, we don't know whether or not do we have the point here, because this is the asymptote. We don't know if this function across this asymptote y equal 1, right? So how do we check this? We check this by blocking the number when y equal 1 and solve for x and see what happens. So y equal 1 will be this equation, right? 1 equal x squared plus 3x over x squared minus 4. So that will give us 1. I'm going to kick this bracket up here. So 1 will time with x squared minus 4 equal x squared plus 3x. Now I'm going to solve for this. I will have an x squared minus 4 equal x squared plus 3x. And because they're both x squared on left and the right, I'm going to cancel out. And I left with minus 4 equal 3x. Divide both sides by 3. I got minus 4 over 3, which is minus 1.33 equal x. So now I know this point right here is as it. The x will be minus 1.33 and very much accurate, right? Because this is minus 1. So over a little bit right here at 1.23. And the y will be 1. So yes, we do have a function across this point. And how accurate it will be. You can see that, right? We don't need drafting calculator. Now, what else do we need to know? We know that our function will go through this point. So we will shape along with this horizontal asymptote and go to this point and go down here to hit this point where we analyzed before. At this point, we will miss one point to complete the graph, right? Complete the graph. And what is our 1 point? You can guess, right? How do we put the pen here? Now we know that our function will go like this and shape along with this, but we're not sure where is our point here and how do we make accurate. So let's inspect. I'm going to make x equal 4 and substitute in this equation to find out, right? If x equal 4, what is y equal? All what we do is substitute back into the function and figure it out. So we have a function of 4 squared, which is this one, adding with 3 times with 4 divided by 4 squared minus 4. So we will get 16 at 12 over 16 minus 4, which is equal to 28 on the top, divided by 12. 28 divided by 12 is about 2.3333. 28 divided by 12. Okay, so now we know our x is 4 and our y is about 2.33. So this is 2, right? Because this is half, this is 1, this is 2. So 2.33, this is 3, so it's above this a little bit. So our point right here, which is 4 for x and 2.33 for y. And therefore, I'm going to shape it like this, along with the x-axis. And anything else we need. I'm going to have to make it a little bit pretty to attract it so that you like my video, right? Okay, so that's how we sketch our rational function, a complex function based on all of this analysis. And that's why I call analysis of rational function. Now, before I teach you this video, I have already shown you a previous video, how to analyze the asymptotes, horizontal asymptotes, how to find vertical asymptotes, and why do we call it asymptotes, what does it mean, and how do we find on the x and y intercept in the previous video. And therefore, I demonstrate again in this video a little bit. I summarize a little bit if we can, but that's how on our work so that we can complete the graph. So let me check with the graphing calculator. As I said that we use technology for helping math, not for replacing math, right? Let's see. If I key in this function, y equal x squared plus 3x divided by x squared minus 4. And I'm going to hit enter and then I'm going to sketch it. How does that look? Does that look exactly the way I draw on the board? And maybe my hand drawing is even look better. Or maybe like I'm biased, but I like my achievement actually. I'm going to mark here. I want the shape a little bit more pretty, but that's how it looks, right? So I hope you enjoy my video. Anyway, so this is how we learn how to sketch the rational function by hand. Also, before I finish the video, let me summarize a little bit. So to get this function, we first find the vertical asymptote, horizontal asymptote. Oh, one more thing I forget. We haven't talked about domain and range. We have to talk about domain and range in here. So let's analyze domain and range in here, okay? So what is our domain for this function? Now, our domain for this function, I don't have to record again. Thanks, lucky. So domain is the set of x on x value, right, along the axis here. That contain our function in there. Now, you can see that by the arrow, right, we know that the x appear everywhere. It go this way, and it go this way as well, except that they're missing some of kind of x in here, right? So what is the domain of our function? Now let's check the one by one, right? Let's check this branch. Our x here is negative infinity, but it doesn't go through this vertical asymptote. So at this point, our x equal -2, right? So from this one here, we can see obviously x is not across this vertical asymptote. So x is a set of x such that x will be different from -2 and +2 because we have a vertical asymptote right there, right? So that's for this one and for this one, right? Because I cannot be +2 and I cannot be -2. So that's, but x can belong to real number, anything x, right? So that's the domain. Yes. Now what else we have for the range? The range is we look at the y value, right? A set of y, and we can see our y is, for this branch, our y is not, our y is not allowed for y equal 1. Let's see. This one is our y is not y equal 1. So for the range, we have to be careful, right? For the range, we'll say y let analyze like this. And let's put in the y can be from negative infinity, right? So we're going to put the round bracket from negative infinity to -2. And including, no, not include, so that, right? So for the first branch, we say our y will be negative infinity all the way down here, up to 1, up to this value, right? And then for the middle one, the branch here, our range will become start from, for this one, start from positive infinity. And let's start from negative infinity to positive infinity. Negative infinity to positive infinity. So this is for our range for this function, right? For the middle one here. So this is a 3 separate branch function, but the whole thing is a whole function, right? But they're separate branch, so we have to analyze one by one. So our range for the first one will be start from negative infinity down here up to number 1 and exclude this value. And the round brackets say exclude, right? Exclude it. So from here up to here. The second range will be from negative infinity all the way up to positive infinity, right? And the third range will be what? And I forget to put in the set of y such that, right? Our y will be a set of y such that will be positive infinity to from 1 to positive infinity. So excluded number 1, so the round bracket to positive infinity. So that's how we state the domain and the range of this function. Okay, so I think that's it for this video. Now, I believe this is a long video as well. At this mentor level, you see that we learn a lot of information. And it's hard in the classroom for the teacher, like sometimes we chop up the lecture into 2 parts or 3 parts, but here on YouTube video and I record it. So it doesn't matter. You can stop. If you're tired, you can rewind and you can come back, right? So I'm going to give you the whole information of one question in here. How to sketch the rational function, how to analyze the domain, the range, the x-intercept, the y-intercept, the asymptotes. And I hope that you enjoy. Thank you for watching and bye for now.